Hello dear students, good evening to all of you. Just do reply, am I audible? Let's start today's class. In the last class we have seen about the Fourier transform basic signals and also we have seen the properties of Fourier transform. In today's class we are going to continue the Fourier transform and we'll start the rectangular signal Fourier transform. All of you guys just confirm audio and video first. Voice is clear to you guys? Good morning Vedai, good morning. Okay. Everything is clear, beta Vedai. Good morning. Okay. So student, just let me know, these all are the questions we have already completed till the last class. Just take a quick revision. What is the Fourier transform of 1? Fourier transform of 1 is 2 pi del omega. Fourier transform of e to the power minus at ut is 1 upon a plus j omega. Fourier transform of e ki power at u minus t will be 1 upon a minus j omega. Fourier transform of ut will be 1 upon j omega plus pi del omega. Fourier transform of e ki power minus a mod of t will be twice a upon a square plus omega square. Fourier transform of real plus even signal will always be a real plus even. Fourier transform of imaginary plus even signal will always be imaginary plus even. Fourier transform of real plus odd will become imaginary plus odd and imaginary plus odd will become real plus odd. This is all about the last class revision, guys. We have also seen the Fourier transform of cos omega 0 t is nothing but pi whole bracket close del omega plus omega 0 plus del omega minus omega 0. Similarly, sin omega 0 t Fourier transform is j pi inside the bracket del omega plus omega 0 minus del omega minus omega 0 and outside the bracket we have coefficient j pi. Is this clear or not, beta? Fourier transform of 1 is 2 pi del omega. Fourier transform of del t is 1. Is it clear, बच्चों? Impulse का Fourier transform 1 and 1 का Fourier transform 2 pi del omega. This is all about the last class revision. Just confirm whether everything is clear, beta. So today's class we are going to start with this question. Just try to attempt this question, beta. All of you guys just try to attempt this. Those who have completed the last class, they can easily solve this question. Do reply how to start this question, how to initiate. What is the problem here, sir? Here, sir, here is the shifting t minus 1, but t minus 1 shifting is not present in this. So that is why how to start, sir? Student, can we start like this? Ki, sir, we know the Fourier transform of e ki power minus 2 t ut and we know that e ki power minus 2 t ut Fourier transform is nothing but 1 upon 2 plus j omega. So if I will provide the shifting t with t minus 1, if I will shift t with t minus 1, then what will I get, guys? Do reply first. If I will replace here, t with t minus 1, then time shifting will be there. So e to the power minus 2, in place of t I am writing t minus 1 and here also u, in place of t I am writing t minus 1. So its Fourier transform will become what? Its Fourier transform 1 upon 2 plus j omega will remain same as it is and here e to the power minus j omega will come into picture. E to the power minus j omega will come into picture. I hope this part is crystal clear to you, beta. I hope this part is crystal clear to you. You guys don't have any single doubt, I hope. Yes. So student, now you will think that, sir, question is not this, sir. What is the question? Now I am just opening this, just open the bracket. So e to the power minus 2t minus minus plus 2, e to the power plus 2 and u of t minus 1 Fourier transform is nothing but e to the power minus j omega upon 2 plus j omega. Now you have to check your question. The question required only e to the power minus 2t terms. It means this question does not require this e to the power plus 2t. It means what I want, I can multiply with both side e ki power minus 2. So if I will multiply, e ki power plus 2 and minus 2 will get cancelled out. So ultimately e ki power minus 2t ut minus 1 Fourier transform will become what, guys? Fourier transform will become e ki power minus, and here inside the bracket will have 2 plus j omega upon 2 plus j omega. So now this is your final answer. I hope this is clear to you. This is the question and this is your final answer. All of you guys just let me know, is it clear or not, beta? Vedai beta, do reply. Is this crystal clear? E to the power minus 2 t minus 1 ut minus 1 से start किया. After that, whatever the constant part which is not required, to compensate that, we have to multiply both sides with e to the power minus 2, so that in the left hand side minus 2 and plus 2 will get cancelled only. Yes sir. चलिए, very good Vedai. चलिए बच्चों, now it's time to start. Okay, this gate question also we can solve. After that, rectangular signal Fourier transform will start. So a real valued signal xt is limited to the frequency of less than equal to omega by 2 is passed through an LTI system whose frequency response is this. So it means, student, h of f is given to you e to the power minus j 4 pi f, and the output of the system is, examiner is asking the output of the system. Now first of all you should tell me beta, if e to the power minus j 2 pi f, if I want to write this term in omega, then I can replace this, I can replace omega equal to 2 pi f. So whatever here 4 pi f is required, if I will divide with 2 pi f here, so what I will get? I will get actually e to the power minus ka twice j omega. Is this clear or not? And we know that, sir, if input we have x of t, input we have x of t, impulse response we have h of t, and output we have a yt, and if its Fourier transform is x omega, and its Fourier ht Fourier transform is h omega, then the output yt Fourier transform y omega will be what? In the time domain, yt equal to convolution of xt and ht, but in the frequency domain, y omega is nothing but the multiple of x omega and h omega. So y omega is multiple of x omega and h omega. So it means, guys, in this equation you will get to know that y omega equal to x omega into h omega. It means what? It means if I am writing the y omega here, my y omega will be what? My y omega is nothing but input signal x omega multiply with this impulse response h omega. What is h omega? E to the power minus 2j omega. E to the power minus 2j omega. So if I will take inverse Fourier transform IFT, inverse Fourier transform, then don't you think the yt will equal to x of t minus 2? Why, sir? Because here time shifting is there, sir, because e to the power minus 2j omega exists in the frequency domain, representing time shifting in the time domain only, representing the time shifting property in the time domain. So yt equal to xt minus 2, it means correct answer is nothing but option number D for Delhi only. Correct answer is nothing but D for Delhi. Whether is it C or D beta? Because minus sign na beta, time shifting always carries same sign. Time shifting always carries same sign na. So electronics for 2014, it is very easy question, very scoring question. You can easily approach this such type of questions. Very nice. So option number D is correct definitely. Now we are going for the next. So EC 14 question completed. Now the Fourier transform of a rectangular pulse. Just make a heading, guys. Fourier transform of a rectangular pulse. Okay. Just make a heading. Fourier transform of a of rectangular signal. Fourier transform of a rectangular signals. Okay. Chali. So what is the rectangular signal? Standard, first of all you have to create the standard rectangular signal, guys. First of all you have to create the standard rectangular signal. So if I will create the standard rectangular signal, then it will be like this. It will be like this. See. So here dear student, here we have a t time domain, here we have a 0, here we have a minus tau by tau, here we have a plus tau by tau, here we have the overall duration tau, and here the magnitude is nothing but a. So this is your standard rectangular pulse, and if I talk about the time domain signal xt is equal to, it will be a into a rectangular of t by tau. It will be a upon a into rectangular of t by tau. Yeah. So this is our standard rectangular signal, guys, and we are looking for its Fourier transform. So whatever the result, we will just make the final result here. We'll just write the final result here only. Okay. So student, you have two choice. Either you can directly go for the formula, same sign time. Yes sir, same sir. Very good. Or you can go for the differentiation property also. So suppose that if I want to differentiate this signal, I am looking for xt, then I am looking for x omega only. But what I am doing here, I am just differentiating the signal here so that it will take less time. Why it will take less time? Because I know it's very easy to write the Fourier transform of impulse signal. It means that it is the step is covering nature. So if I am looking for dxt upon dt here, then tell me guys, exactly at minus tau by 2 location what will happen? So exactly at minus tau by 2 location what will happen? Plus tau by 2 location again what will happen with respect to t? So here you will say that sir, amplitude is nothing but plus a, so you will have a plus as of a and at the location of minus tau by 2. It means while the process of differentiation, the magnitude of step will become the weight of impulse. The magnitude of step signal will become the weight of impulse because it is a positive a. So that is why plus a का एक rising edge आ गया. Now till here you have already completed. Now from here to here when you will see a ulta step, you will see a reverse step, so that you will get the reverse, or we can say the falling impulses, which is having the magnitude minus a, which is having the weight minus a. So it means if this is my x of t signal, then this is my dxt upon dt signal, and if I will write my dxt upon dt equation, then dxt upon dt equation will be look like a into del of, so I am writing here a into nature is del, location is minus tau by tau, so it will become actually t minus plus tau by tau, and next amplitude is minus a del of t minus tau by tau. I hope till here everything is clear. How we can write this equation from the curve, you know very well, we have discussed already in chapter number 1. Now student, you have to take Fourier transform both sides. So just write Fourier transform both sides. When you will take Fourier transform both sides, what you will get here? Dxt upon dt, if xt is Fourier transform x omega, then dxt upon dt is having the Fourier transform j omega x omega, and is equal to what? A into del t plus tau by tau, it means e to the power plus j omega tau by tau, and here is what? Minus a, again you should write here e to the power minus j omega tau by tau. So ultimately what you will get guys, you will get j omega into x omega, and here what you will get common a, what you will left inside the bracket? So you will left inside the bracket is twice of j into sine of, sine of, बोलो बच्चों, omega tau by tau, sine of twice of omega j by tau. I hope this part is also clear to you बच्चों, yes or no? I am just writing in terms of sine. Is it clear whether he till here, whether he? So I am writing this complete box in the next slide. We will do some modification because we know that we have opportunity to convert this function in the sampling form. So right now the expression is, now I am cross multiplying j omega also. So x omega equal to what? If the j omega cross multiply, this j omega term cross multiply right side, so a upon j omega it is. So a upon j omega, a upon j omega, a upon j omega, a upon j omega, and 2j inside the bracket. What we have inside the bracket? We have 2j into sine of what guys? Omega tau by 2, omega tau by 2. Yeah. So now what you will get guys, don't you think j get cancel out? So ultimately sir, your x omega will be look like this कि sir a यहाँ है and omega What I want to write sine of omega tau by 2. So if I want to write in terms of sampling, in the denominator I need to create omega tau by 2. So do you think that omega I already have? Omega I already have. 2 I don't have. Should I multiply 2? Yes sir, multiply. So now tau get cancelled. And 2 I have. So in numerator, instead of writing 2 in numerator, I am writing 1 by 2 in denominator. Yes sir. So now we can write like this. So you can just focus on this part. It will give you the sampling form, guys. So now your x omega will become what? Your x omega will become tau A, or you can say that A tau sampling of omega tau by 2. A tau sampling of omega tau by 2. So this is the final result. This is the final result of Fourier transform for a rectangular signal. This is the Fourier transform of a rectangular signal. So x omega equal to A tau sampling of omega tau by 2. A tau sampling of omega tau by 2. I hope this part is clear to you, beta. Is this clear? All of you guys just let me know, yes. Chali. So now the final result is what, guys? A tau rectangular Fourier transform is nothing but A tau sampling of omega tau by 2. Fourier transform is nothing but A tau sampling of omega tau by 2. I think till here everything is clear. You guys don't have any single doubt. I hope it is clear. So rectangular signal A rectangular T by tau, Fourier transform is nothing but A tau. It means this is A, this is tau. So area, you can also remember the area of the rectangular signal is the multiple of the sampling. For rectangular pulse, area is A tau. So A tau is the scalar, A tau is the multiple of the sampling function in the frequency domain. Complete? Yes. So it's a very important result, guys. You have to again make it a box. I am just making as a box for you. And going forward, this will become as a formula because questions will come from this topic. All many questions examiner can frame from this topic. So minus tau by 2 to plus tau by 2, T as comparisonly, here it is tau, it is my A. So if I will take its Fourier transform, I will get actually A tau sampling of omega tau by 2. So I hope till now everything is clear. So I hope till now everything is clear. Yes sir, clear. So it will be A tau sampling of omega tau by 2. Every student just let me know, beta, shall we go for next? All of you guys just let me know, shall we go for next? Is this completed? Chali. So students, similarly, if I am looking for the Fourier transform of a triangular pulse, chali, triangular pulse पे बात कर लेते हैं. Here is a triangular pulse, okay. So Fourier transform of a triangular pulse. How to write the Fourier transform of triangular pulse? After that, examples will come, okay. So Fourier transform of a triangular pulse. Fourier transform of a triangular pulse, okay. Fourier transform of a triangular signals. So if I will make the Fourier transform of triangular signal, the triangular signal will be look like this. The triangular signal will be look like this. See. So the signals will be, shall I write like this, guys? Make this equation like this and like this. So here is 0, here is minus tau, here is plus tau, here is with respect to t, here is the amplitude A, and this is my signal x of t. Is this clear, beta? So this is my triangular pulse. I want to differentiate this, or I want to make the Fourier transform of the same. I want to find the Fourier transform for this same, okay. So student, Fourier transform of this same, again I am using the differentiation. I am just differentiating this signal. So I am using this signal on the next slide so that I can make differentiation in a just below to this. So I am just making this diagram right now, like here. I am making this diagram here. After that, just below to this, I will make diagram like this. Yeah. And just below to this, because 2 time differentiation is required, so that is why I am just making some space here so that it is easily the diagram you guys can see on the board. Yes or no? Chali. So now tell me, if my triangular pulses look like this, guys, if this is my triangular pulse, this is my triangular pulse x of t, this is my 0, this is my minus tau, this is my plus tau. So this time what is the width? The width is 2 tau actually, है ना? So this is a confusion generally student having. In the rectangular pulse, the overall time duration is tau minus tau by 2 to plus tau by 2. But here is the overall width of a rectangular pulse is 2 tau. But as far as area is concerned, it is also a tau. Why? Half into width into height. So its width is 2 tau and height is a. So half into 2 tau into a, the area will be a tau only. So now student, if I am differentiating this signal dxt upon dt, if I will differentiating here, tell me what I will get at minus tau, what I will get at 0, what I will get at plus tau. So while the process of differentiation, the magnitude of step will become the weight of impulse. At the same time, while the process of differentiation, the slope of a ramp signal will become the magnitude of a step signal. It means whatever the slope of this ramp you have to calculate, whatever the slope of this ramp you have to calculate. What is the slope, guys? Slope is nothing but difference in y upon difference in x. So slope is nothing but a by tau. So for this slope you have to create the magnitude. So it means I need to make a step signal which is having the magnitude of a by tau. So difference in y upon difference in x, so a by tau. Now what will happen here, guys? The signal is going like this. When it will come to the horizontal line, you already achieve 0 value. After that, student, when you are touching this line, you have to calculate the slope of this line. So slope is nothing but what, guys? Here slope is because decreasing line, so minus, and a upon tau, so minus a by tau. So from here, if I will travel minus a by tau, I will just reach here minus a by tau. And after that, student, we have a constant line. Constant line differentiation is 0 always. So wherever you are, you will reach to 0 only, just like this, and after that. So you will see that the differentiation of a triangular pulse is nothing but the square waveform, just like this. And student, it is also an important point that the differentiation of even signal will become odd. Do you know that the triangular function is symmetrical about y, so it is nothing but a even signal. So shall we say that if I will differentiate a even signal, I am getting a odd signal. I am getting a odd signal. Now again I am differentiating, guys. Again I am differentiating. So d2xt upon dt square. Come on. If you will differentiating again, you should tell me at minus tau location what you will get, at 0 location what you will get, and tau location what you will get. So because now it is a step, so while the process of differentiation, the magnitude of step will become the weight of impulse. So it means here you will get a impulse. Here you will get a impulse of a by tau weight. Similarly, at t equal to 0, you will get the impulse of minus 2a by tau. You will get the impulse of minus twice a upon tau. Similarly, at the tau location, you will have a edge of rising edge of a magnitude a by tau. So you will have a impulse of a by tau weight. Yes. So now I am writing the equation of d2xt upon dt square, guys. So when I will write the equation of d2xt upon dt square, just do reply what I will get. So d2xt upon dt square is nothing but a upon tau into del of t plus tau, minus का twice a upon tau into del t, and again we are having plus a by tau into del of t minus ka tau. So when you will take Fourier transform both sides, guys, tell me, when you will take Fourier transform both sides, do reply what you will get. Fourier transform both sides, it means you will get j omega x omega, you will get j omega whole square x omega equal to a upon tau into e to the power plus j omega tau minus ka twice a upon tau into del t Fourier transform is 1, and again you will get plus a by tau into e to the power minus ka j omega tau. So now ultimately what you will get, guys, you will get x omega outside the bracket, sir, 1 upon j square, it means minus ka omega square whole bracket close. Now tell me here, a also I can take common, na? A also I can take common, sir, yes. A also I can take common, tau also I can take common. So what is inside the bracket? E to the power plus j omega tau minus ka 2 and plus e ki power minus ka j omega tau. All of you guys tell me, is this completed, beta? Vedai, just do reply. Vedai, beta, just do reply. I just common and cross multiplied. So j omega square means minus omega squared. Tau common. So e की power j omega 2 minus 2 and plus e की power minus j omega. That's it. Now tell me बच्चों कि if I will write this x omega as a upon minus का omega square tau तो है. Now here just let me know if I will just add first part and last part. Don't you think I will get twice into cos of omega tau and minus 2 ये. And if I will take minus 2 common, then what is left inside? Minus omega square tau in denominator, so minus minus plus also. And what is left inside now? Because minus 2 common, so inside the bracket 1 minus cos omega tau only left, sir. So this is my final expression, guys. This is one of the form that you need to remember because sometimes this form also mentioned in the options. So this is the one form that you should also remember, twice a upon omega square tau into 1 minus cos omega tau. This is the one form. This is the first form. The second form we always want to convert in sampling so that we can relate the expression in rectangular also and regular form also. So if I want to convert this function into sampling, then 1 minus cos, can I convert this sine square formula? So whatever the result I am just writing here, x omega equal to twice a upon omega square tau. So it will be twice a upon omega square tau, twice a upon omega square tau, a upon omega square tau, 1 minus cos omega tau. So I am writing inside the bracket 1 minus cos of omega tau, 1 minus cos of omega tau, 1 minus cos of omega tau. So just do reply fast, guys. Here what you will get here x omega equal to twice a upon omega square into tau, and here 1 minus cos omega tau is nothing but actually twice of sine square omega tau by 2. Twice of sine square omega tau by 2, twice of sine square omega tau by 2. So what you will get ultimately, guys? You will get ultimately x omega equal to 2 to the 4 into a, 2 to the 4 into a into omega square into 2, and here you will get what? Here you will get sine square omega tau by 2. Sine square omega tau by 2. So now ultimately you should tell me, beta, what is x omega? X omega will be what? X omega will be a into, if I want to write sine square omega tau upon 2, if I want to convert this expression in sampling form, then I need to generate omega tau by 2 ka whole square in the denominator. So I have already omega square, I have already 1 tau, but if I multiply with one more tau, I can have tau square also. And this 4 in numerator, I am writing 1 by 4 in denominator, just like this. So now I think you will get ki omega square covered, tau square covered, 4 covered, a already covered and tau multiplied. So now I can write, student, a tau sampling square omega tau by 2. So now this is my final result that you need to remember as a box. Do reply fast. Is it clear or not? Do reply fast, beta. Sir, live class की timing क्या है sir? अंकिता पांडे. अंकिता live class 11 AM पे start होता है बेटा. Morning 11 AM पे अंकिता. If you are a new student, beta, this is I think 30 or 31st, whatever the sequence of this lecture. You can also find time and complete the recording. Okay, we have the classes morning 11 AM on weekdays. Okay, so do reply fast, guys. Shall we go for next? Do reply, guys, and you should subscribe the channel, bachcho, so you will also get the information of the live classes in the upcoming live streaming. You will get the lectures in advance. Do reply, beta. Shall we go for next? So what is the result now? The result we need to store in a box, just like this box. The box is nothing but a tau sampling square omega tau by 2. A tau sampling square omega tau by 2. So here what you can write, guys? You can write like this. You can write like this. So it is a tau sampling square of omega tau by tau, and this is my triangular signal and this is sampling square signal. And if I will just revise the rectangular pulse also, so rectangular pulse comparison always with minus tau by 2 to plus tau by 2, and here is 1, and Fourier transform is nothing but actually a tau sampling of omega tau by 2. Okay. So this is the Fourier transform of rectangular pulse, and this is the Fourier transform of a triangular pulse. बोलो बच्चों, यहाँ तक की बात कंप्लीट है क्या? अंकिता, whether he do reply बेटा. So Ankita, you will have a sufficient time because next week I am actually out of Bangalore, so I am not able to take the class. So from the next week we don't have any class. Next week again we'll start. Okay. So meanwhile, what you will do, Ankita, whatever the lecture 30th lecture we have completed till now, you should just make a separate notebook and try to complete that lectures. Okay, in recording form. And whatever your experience you can write in comment section also. Okay. चलिए, अब बताइए बच्चों, ये बात कंप्लीट. शैल वी गो फॉर एग्जांपल्स नाउ? यस. सो नाउ टेल मी व्हाट इज द आंसर फॉर दिस. कम ऑन, कैन यू प्लीज सॉल्व दिस एग्जांपल? टेल मी व्हाट इज द फाइनल आंसर. So now sir, it is very easy to compare. It is very easy to compare, sir. Sir, it is minus 7 by 2 to plus 7 by 2. It is this. So what is tau? So minus 7 by 5 to plus 7 by 5 is nothing but 14 by 5. So we can simply write a tau sampling of omega tau by 2. This is nothing but my Fourier transform. So what you should write? You should write a matlab 10 by 21. A tau matlab 14 by tau matlab क्या बच्चों? 14 by 15. 14 by 5. 14 by 5. 14 by a tau sampling of omega tau by 2. What is tau by 2? 7 by 5. ये 7 by 5. So it means your final answer is 7 2 ja 24, 7 3 ja 21, 5 2 ja 10. So don't you think 2 2 ja 4? So it will be 4 by 3 into sampling of 7 omega upon 5. I hope this part is clear, beta. Just do reply, प्यारे बच्चों. This part is clear or not? Just do reply, बच्चों. 4 by 3 sampling of 7 omega by 5. Is this clear to you? Is this clear to you, प्यारे बच्चों? Sir, कर लूँगी जल्दी से. मैंने आपका कंट्रोल का रिकॉर्डेड लेक्चर देखा है, बहुत ही बढ़िया है सर. Very good, beta. Ankita, very good. Ankita Pandey, thank you so much for your lovely words, and definitely I want that you will come in the next live class after completion of the 30 lectures. Okay. So we'll meet again in the next upcoming class. However, this class also you can continue if you wish. So here this is a simple concept. We started rectangular pulse Fourier transform of this. Chaliye. Thank you Ankita for your lovely words, beta, and just share your experience to all your juniors, all your colleagues also, if it is possible. If you are right now doing engineering, and then if you have a contacts, if you have any, if you know any juniors, they are also preparing for the GATE. If you know any your friends, they are also looking for the good GATE preparation, then just share your true experience. Okay, जो भी आपका सच्चा experience है, दिल से सबको बताइएगा. That is the one way to say thanks also. चलिए, now student, this question completed. I am going for the next बच्चों. I am going for the next. Now my next question is, I think diagram is clear to you. It is xt and I am looking for its Fourier transform. Question is find its Fourier transform. Question is find its Fourier transform. So now this time I am expecting this question from you all guys. Tell me, try to solve this. Vedai, can you try to solve this? Yes sir. Very good, beta Ankita. Try to solve this question and tell me what is the correct answer. I am giving you 1 minute time. I am giving you a hint, guys. This signal you guys can generate by adding 2 rectangular pulse. Just apply your concept and you will get the answer I am telling. If you will attempt it, Purushottam, good morning, beta, good morning. Purushottam think that the class will start at 11:30, so he is coming at 11:30. No problem, Purushottam, you can complete the remaining part in recording, okay? Chali. So whether he replied the question, I am just repeating last question for the Purushottam saying that. So Purushottam, what we have concluded beta, we have concluded these two results, okay. So because you came late, so here this is the first conclusion beta. A rectangular signal Fourier transform is always a tau sampling of omega tau by tau. So whatever the omega multiple tau by tau, you can compare with this from this, and a means amplitude and tau means this overall duration. So it will be a tau sampling of omega tau by tau like this only. Now student, this is the rectangular pulse and this is the Fourier transform, always write in terms of sampling form. And if I talk about the triangular signal, then triangular signal Fourier transform is what? A tau. But here what we need to remember, ki here the duration is minus tau to plus tau, whereas in the rectangular the duration was from minus tau by 2 to plus tau by 2. Here the triangular Fourier transform is a tau sampling square omega tau by 2. I am very happy that whether he has replied correct answer. So now we are solving this question. Sorry. Chaliye. This question. Minus 2 to plus 2, we have a rectangular nature here, 1 and after that 2. So can I generate this signal by adding these two rectangular pulse, guys? I am making one rectangular pulse here only, so that you can relate. One rectangular pulse is from minus 2 to plus 2. Minus 2 to plus 2, and here is 1. So minus 2 to plus 2, here is 1. It means what is the transfer Fourier transform, guys? Now the Fourier transform is nothing but, देखो, first of all I am just making two signals. This is the first signal, this is my second signal. Yeah. So minus 2 plus 2 1, and here I am making the signal with minus 1 to plus 1, and here this is 1. So now tell me, if I will add these two signals now, then from minus 2 to minus 1 we have 1 only, and from 1 to 2 also we have 1 only. And after that, but between minus 1 to plus 1, here is also 1, here is also 1. So 1 plus 1 will become 2. So now you should compare ki what is the individual Fourier transform of this. Because you know that ki rectangular signal Fourier transform a tau. So you should compare here a value 1 and tau value is 4. So what you will write? The Fourier transform is nothing but a tau matlab 1 into 4 into sampling of omega tau by tau. Tau by tau is here 2. So it is nothing but 2 omega a. So this Fourier transform is this, and plus we have to add the Fourier transform this also. So what is tau overall? Overall tau is 2 only, sir. Overall tau is 2 only. Minus 1 to plus 1. Magnitude is 1. So what you should write? You should write a tau sampling of, so a value 1, tau value 2, sampling of omega tau by tau. Tau by tau value is 1 here. So 1. So it means the final answer that you are supposed to write x1 omega. This is your x1 omega. This is your x2 omega. You have to add both. So when you will add, what you will get? You will get 4 into sampling of 2 omega. You will get 4 into sampling of 2 omega plus 2 into sampling of omega plus 2 into sampling of omega. All of you guys just let me know, is this crystal clear beta? 4 sampling of twice omega but twice sampling of omega, is this crystal clear? Whether he already replied the same, 4 sampling of twice omega but twice sampling of omega. Very good. Chaliye, now we are going for the next bachcho. So what is the Fourier transform of impulse function? Impulse function Fourier transform is 1. Rectangular Fourier transform is nothing but sampling a tau sampling of omega tau by tau, and triangular is nothing but a tau sampling square omega tau by tau. Yeah. Chaliye. Tell me, can you solve this question within 7 seconds or maximum 17 seconds? This is a engineering services 17 question, guys. Can you solve this question in 17 seconds? Sorry. All of you guys just do reply fast. Shall we go for next? Very nice. B for Bombay only. Kamran. क्या बात है Kamran. शाबाश. You just need to compare A tau sampling of omega tau by 2. So what is A guys? A is nothing but 1 sir. Tau is nothing but -1 से लेके 1 मतलब 2. And sampling of omega tau by 2 is nothing but 1 only. So 2 sampling omega is your answer only बच्चों. 2 sampling omega, and how the sampling open? It will be sin omega upon omega. So 2 sin omega upon omega मतलब option number B for Bombay. That's it. So it's a engineering services 17. It is a gifted question. You just know the standard form. You can apply and you will get the answer. T by 2 से ऊपर वाला चला जाएगा sir. Very good, very good. So tau by 2 का value 1 आ जाएगा directly. So you will get the answer. I think option number B you all are getting the same. Student, here is my triangular pulse. So of course you will say that sir, this is one of the triangular pulse, this is another of the triangular pulse. So shall I say that if this signal is, if I will take as a F1t and F2t, then xt is nothing but the addition of F1t plus F2t. Just do reply guys, tell me yes or no. So like that student, you can find the Fourier transform of this. You can also find out the Fourier transform of this, and you can just add. And you know the Fourier transform of triangular pulse. You know the Fourier transform of triangular pulse. Is it clear or not? So shall we go for next bacha? You can just add this and you can solve this, yes or no? Or what is the conventional approach? Sir, conventional approach, sir, if you don't use this, so can you differentiate this function? So when you will differentiate one time, you will get such type of nature. When you will differentiate one time, you will get such type of. Again, this is xt, then this is dxt upon dt. And again, when you will differentiate twice, then it will become impulses. Here rising edge, falling edge, rising edge, and you can write the equation as well. Yes or no, beta? So how can you write in terms of, suppose that if I will write, sir, my ft signal is this, okay. Suppose that if I will write in terms of my triangular standard form, then don't you think, suppose that, sir, this is what 0, this is what -1, this is what +1. Let us assume that this is the amplitude 1 and this is my ft. Then tell me what is its Fourier transform. Tell me what its Fourier transform. So Fourier transform A tau sampling. So A भी 1 है, tau भी 1 है. A tau sampling square omega tau by tau. What is tau? Tau value 1. So tau by tau मतलब sampling square omega by. ये ft का Fourier transform है. ये ft Fourier transform है. Then don't you think कि xt is nothing but बोलो बच्चों, xt, this xt I am writing here x of t. So this xt is nothing but what? कि sir, this ft function you have to shift 3 distance in the right hand side, then you will get this function. So don't you think if this is my ft, then with respect to ft, this is nothing but f of t minus 3. And this is nothing but this is shifted in the left hand side by 3 distance. So don't you think it is my ft plus 3? So ultimately, if I am looking for the Fourier transform both sides, so I should write x omega equal to ft minus 3. So ft ka f omega, what is f omega? F omega is, sir, sampling square omega by 2. And time shifting always carries same sign. So e to the power minus 3j omega plus ft again, what you should write? You should write sampling square omega by 2. And again, what you will get? Here you will get e ki power plus 3j omega. Yeah, e ki power plus 3j omega. Ultimately, if you want to take common, then you can also write x omega as a sampling square omega by 2 as a common, and inside the bracket you will get e की power minus 3j omega और e की power plus 3j omega मिलके बनाएगा twice of cos of 3 omega. Is this clear or not, beta? This is your final answer. How many of you are getting this? Do reply fast. क्या बात है वैदेही, शाबाश, super, very good. Twice sampling square omega by 2 cos 3 omega. Very good. So this is how you guys can relate with this. It is very easy question, or this is the conventional approach, this is lengthy approach. We should use this form because we know the standard. Yes, sir. Right. Very good. Chali. Shall we go for next part? Pyare bachcho, just do reply. Yes. Okay, this electrical 2014 question I am expecting from you. Do you want to try this question, guys? I am giving you 2 minute time. Just have your attempt, guys. Just try to have your true attempt. Okay, you should have your true attempt, please. All of you guys, just try to attempt it fast. sorry. All of you guys try to have your true attempt बच्चों, just try to attempt. Vaidehi, Purushottam, tell me which option correct, beta. Option number B, option number A. A says that by Vaidehi and B by Purushottam. Okay, okay, okay. Very good, very good. Chaliye. So let's see. First of all, what is the meaning of xt? So xt meaning is nothing but mode of. So xt meaning is what, guys? Xt meaning. So if I will make a curve for xt is nothing but my rectangular pulse, which is having the time duration from -1 to +1. Magnitude is 1. This is the time domain, and this is my x of t signal, guys. Yeah. The Fourier transform of the convolved signal yt equal to x2t and xt by 2. So what it will be? So let's see. So tell me, student, do you know time shifting property? If I talk about ki x of 2t convolution with x of t by 2. If I will write x of 2t, convolution with x of t by 2. So what you will get here? Sir, convolution in time is nothing but multiplication in frequency, sir. So if I talk about x of 2t first of all, tell me what is the x of 2t curve? X of 2t matlab it is compressed. It is compressed matlab the new curve will be from -1 by 2 to +1 by 2. Magnitude is still 1. Similarly, convolution of rectangular pulse xt by 2 matlab this time it will expand. It will multiple by 2, so it will be -2 to +2, magnitude 1. So suppose that it is my x1t, it is my x2t, and it is convolution in time. So convolution in time is nothing but multiplication in frequency. If I will write its Fourier transform here, and if I will write its Fourier transform here, if I will write its Fourier transform here, then I just need to multiply both, yes. So what is the multiply? A tau, it means A is 1, tau is also 1. So sampling of omega tau by 2, what is tau by 2, guys? Half only. Similarly, what you should write here? A -2 se leke +2, so it will be 4 into A tau sampling of omega tau by 2. What is tau by 2, guys? Tau by 2 is nothing but 2 only. Tau by 2 is nothing but 2 only. Is this clear to you? So your final answer is nothing but 4 into sampling of 2 omega. 4 into sampling of 2 omega into sampling of omega by 2. So just convert sampling into sine. So you will get what? 4 into. So you will get what, guys? 4 into sine. 4 into sine of 2 omega upon 2 omega. Similarly, you should write here sine of omega by 2 upon omega by 2. So this 2 and this 2 get cancelled out. So the final answer is nothing but 4 into sine 2 omega dot sine omega by 2 upon omega square. So 4 into sine omega by 2, sine 2 omega, 4 upon omega square. Option number A for Ahmedabad is only correct, guys. Option number A for Ahmedabad is only correct. Yes or no? Beta Purushottam, you are getting or not now? Electrical 2014 question. I hope it is clear to you, bachcho. I hope this question is crystal clear to you. All of you guys do reply fast. Shall we go for next? बोलो बोलो जल्दी बोलो यार, फटाफट से बोलो. Shall we go for next? Vaidehi, Purushottam. चलिए. Now electrical 2008 question, 2 marks question. This question also we can solve by using 2 approach. So whatever approach coming in your mind, do you want to try this question, guys? Just want to attempt. I'm just giving you a hint. If those who want to attempt, just do it first, guys. So here is xt. I'm just making the curve xt is equal to rectangular of t minus half. What is the meaning of rectangular? Rectangular is 1 for minus half to plus half. So suppose that if I'm making the curve of rectangular of t only, tell me, guys, what is the rectangular of t curve? Rectangular of t curve having the magnitude 1, rectangular of t curve having the magnitude 1 for which distance? From minus half to plus half, sorry. And here what is the magnitude, sir? 1. So rectangular from minus half to plus half, here one rectangular. And what about xt? Xt is nothing but rectangular of t minus half. So all of you tell me, what about xt, guys? So xt signal is nothing but rectangular of t minus half. It means what? A rectangular of t minus half, it means we have to shift this signal by half distance in the right hand side. So if I will shift this signal by right hand side, half distance, so I will get this signal 0 as 1, 0, 1. And what I will get here? I will get 1 here. So don't you think it is nothing but rectangular of t minus half? And actually it is nothing but what, guys? Actually it is nothing but x of t. All of you guys do reply. So now I have my xt from 0 to 1, this signal. After that, examiner is asking for find out the Fourier transform xt plus x minus t. I have already given hint to you guys. Now xt is already there for you. Just need to make x minus t and take the Fourier transform and just add, you will get the answer. Now next, whatever the steps are required, 3 or 4, I am expecting these steps from you only. All of you guys just try to give your true attempt and try to solve this. Electrical 2008, 2 marks question it was. Try to attempt. Every student just do reply. Shall we go for next? Tell me which option. Sir, we have already did, sir, but no option is matching, sir. Tell me which option is correct. Which option is correct? Are you getting which option? Every student just do reply. NOW बच्चों. Shall we go for next? Okay, Vedai says that B. Okay, चलिए. Now student, it's time to explain. I'm explaining this question, just try to focus on the board. So xt plus x minus t, it means xt is my this curve, okay? Xt is my this curve, sir. Of course, sir, xt is curve from 0 to 1, 0 to 1, 1. And this is your x of t. And plus x of minus t, plus x of minus t means, so this is your x of minus t. This is your x of minus t from 0 to minus 1, ye on your x of minus t. So just let me know, beta, if I will add these two curve, what I will get? Don't you think here is discontinuity, discontinuity, so half half, so again it will be 1. So it will be overall signal from minus 1 to plus 1, 1 only. So this is the only my answer, this is my only xt plus x of minus t. And I am looking for its Fourier transform. And don't you think it is very easy? The Fourier transform is a tau sampling of omega tau by tau, that's it. So what is a? A is 1. What is tau? Tau is minus 1 to plus 1, it means tau value is 2. So a tau matlab twice sampling of omega tau by tau. Tau by tau, what is tau by tau? Tau by tau 1, yes, again. So your final answer is nothing but actually twice of sampling of omega. This is your final answer, but when you will see in the option, you will get to know, sir, this is not given in the options. And when you will observe option clearly, you will also observe, sir, here all the options are in sync form, not sampling form. And omega is not omega by 2, omega by 2, omega by 2, omega by 2 is given. Omega by 2 pi means, because it is converted in sync, that is why pi. But if I will write in equivalent sampling, then of course omega by 2 will come. And what is my angle here? My angle is sampling of omega. It means from here you will get to know what you need to do. You have to apply some trigonometry after this also. After this also you have to apply some trigonometry to achieve the final desired form. So can I convert this function into sine? Yes, sir. So it will be twice of sine of omega upon omega. Yes, sir. I just converted sampling omega into sine omega. Now the next equation, what we should write, guys? The next, sir, we can write as a 2 upon omega as it is, sir. But because the angle is omega by 2, so what is sine 2 theta formula? 2 sin theta cos theta. So it will be 2 into, shall I write, bachcho, sine of omega by 2 into cos of omega by 2. Now if I will write this formula, then final equation will become 2 2 ja 4 omega into sine of omega by 2 into cos of omega by 2. यहाँ तक भी कोई दिक्कत नहीं है, sir. Now student, in the examiner, in the options, actually first form convert into sampling or sync. So I am writing like this, I am writing 4 upon omega. Instead of 4 upon omega, I am writing 2 upon omega. And I am writing here sine of omega by 2 upon. This omega I am also writing here. This omega also I am writing, and omega by 2 I am writing here. Because 1, 2 here, earlier here 4 na. So 2 2 ja 4 now. Into cos of omega t as it is. So now don't you think, sir, it will become actually twice into this complete gola. This gola will become sampling. So it will be sampling of omega by 2 into cos of omega by 2. Yes, sir. Now if I want to convert this sampling function into sync, then it will become what? Sir, SINC sync of, it will become omega upon 2 pi dot cos of omega by 2. So I think till here everything is clear, pyare bachcho. Just do reply fast. So I think till here everything is clear. So it will be twice of sync of omega by 2 pi dot cos of omega by 2. Twice of sync into omega by 2 pi dot cos of omega by 2. And it is nothing but actually mentioned in the option number C for Chennai. I think option number C for Chennai. C for Chennai Super King, guys. Correct answer C for Chennai. CSK. CSK. बोलो बच्चा CSK. हाँ या ना? CSK. So that is why it's a very good question, because this is the only correct answer, but still to achieve the desired option, to get the desired option, you have to apply the trigonometry. Okay, sir, I was a bit confused because of sync and sampling, but now it's clear. So I am also giving you clarity, bachcho, sync or sampling. Let me take about this. If I am writing this sin t upon t, then sin t upon t is equivalent to what, bachcho? Is equivalent to sampling of t only. Equivalent to sampling of t. And do you know what is this? Sine of pi t upon pi t. It is actually equal to what? SINC, sinc of ta. Now, do you know that if I want to write this function into sampling form, then don't you think it is equal to actually sampling of pi t? Why, sir? Because in the sampling form, whatever is mentioned in the bracket after sine, that will come here and it will be sampling. So here it is sine pi t upon pi t. So in terms of sampling, it will be sampling of pi t. So it means, don't you think that sampling of pi t is nothing but sinc of t? Yeah, shabash sir. Yeah. Sampling of pi t is nothing but sinc of t. This is the relation. Similarly, प्यारे बच्चों, don't you think कि sir ये sin of t upon t is sampling of t? So don't you think I can write sinc of t by pi? How, sir? How sinc of t by pi? So sampling of t is nothing but sinc of t by pi. How? Because sinc will open like this. Sin pi into whatever in the bracket. So what is in the bracket? In the bracket is t by pi. Upon pi into whatever in the bracket. Whatever in the bracket. What is bracket? Bracket t by pi. So t by pi. So pi cancel pi. Sin t upon t is nothing but sampling. So this is the important relation you have to remember. Sampling of t is nothing but sinc of t by pi, and sinc of t is nothing but sampling of pi t. Both the relation you need to remember, guys. Both the important equation you need to remember. All of you guys just do reply fast. Is this completed, beta? Is this completed to you? चलिए, okay प्यारे बच्चों. So that's all from today's class बच्चों. We'll meet in the next class. As I told you, next class I will not available. So that is why we'll meet in the next week now. Okay. And those who are looking for the complete GATE preparation from the IMS GATE Academy, you can just contact to the student advisory team. The number is given in the description बच्चों. You can also get enrolled in the zero fee program, where you will get the free access of the lectures, PDFs and many more. And student, those who will enroll in the IMS GATE Academy program, you will get 800 plus live lecture access. You will also get 130 plus test series that will contain subject test, multiple subject test, advanced subject test, as well as the mock test. Also, you will get 26 to 30 hard copy of booklet, that is theory book and exercise book. You will also get, my dear student, dedicated doubt solving portal and one-to-one mentorship sessions. Okay बच्चों, so that's all बेटा. वैदेही पुरुषोत्तम, बाय बाय, टेक केयर बच्चों. That's all from today's class. ऐसे ही मुस्कुराते रहे, हंसते रहें और शेयर करते रहेगा. सर आज की क्लास कितने टाइम से स्टार्ट हुआ था सर? आज बच्चों क्लास 11 बजे स्टार्ट हो गया था. 11 AM एग्जैक्ट स्टार्ट कर दिया था हमने. जनरली लास्ट क्लास थोड़ा 11:30 हुआ था, तो पुरुषोत्तम सोचा था कि 11:30 होगा. बट एक्चुअली कभी कभी इन द बैंगलोर एक्चुअली वी हैव अ ट्रैफिक बच्चों. सो ट्रैफिक से कभी लेट हो जाते हैं तो 11:30 हो जाता है. अदरवाइज जनरल टाइम हमारा 11 ही है. ओके चलो. ओके, सो दैट्स ऑल फ्रॉम टुडेज क्लास बच्चों. बाय बाय, टेक केयर. वैदेही पुरुषोत्तम. ऐसे ही पढ़ते रहें, मुस्कुराते रहें, हंसते रहें और अपना बेस्ट एफर्ट करते रहें. डेली बेसिस पे अपना बेस्ट एफर्ट करते रहें प्रिपरेशन के लिए. ओके बच्चों, चलिए बाय बाय बच्चों, टेक केयर.